Hello everyone, my name is Talib. I'm the founder of Hazelcast. What is Hazelcast? It's an open source in-memory data grid solution. Alright, so who's using Hazelcast? Most of the... Oh, who's using? Yeah, really? Yeah. Is there anyone using here? One here, one here, one here? Okay, it's quite a lot. Very nice. Anyone who didn't hear anything about Hazelcast? All right, that's good. Okay. So who's using Hazelcast? A lot of the big companies. If you're working for a very big company, probably one group in your company already using Hazelcast. Look for them. Every second, a new Hazelcast instance starts in the globe. Gartner thinks that this year we're cool. So in case you're wondering. Hazelcast is growing. It's the 9th fastest growing skill in LinkedIn. Please, if you're a Hazelcast user already, add Hazelcast as a skill so that we can be the #1. The keywords we're talking about: in-memory data grid, elastic cache, NoSQL. These are the things that we're really talking about here. So basically, everybody knows HashMap. We're at Java 1. So it's not thread safe. If you want to make it thread safe, of course you have to use something like concurrent HashMap. And now you can share that map across threads right now. Right. So we should, and the question is, what if you want to share this map across multiple JVMs? Okay. How can you do that? And what's the code for this? And here's the code. Hazelcast get map. Now you have the map. The JVMs touching Hazelcast will auto-discover each other and form the cluster. And then if the name of the maps are the same, then you're looking at reading the same map. We also support queues and multi-maps. We're going to come to that. So let's... so why Hazelcast? Because we want to build highly scalable, available applications, right? So alternatives, Oracle, Coherence, Gigaspaces, IBM, InfiniSpan, Terracotta, Gemstone. It's not Gemstone anymore, VMware, Gemfire. Okay? So we'll just make sure you know all that so that, and also try please, so that you can love Hazelcast more. First of all, I admire all of these products. I think they're brilliant products. I'm a big fan of all these products. So, of course, Hazelcast is a little better. So difference is license, cost, feature set, easiness, and main focus. Like some of them are more tuple space processing. Some of them are more distributed cache. Some very light, some very heavy, and that's why we came up with the Hazelcast, and we thought it should be really free in freedom term, right? Freedom, free. So it's very lightweight. It's a 1.7 megabyte single jar that you put into your ClassPath. That's what it is. It has no dependency. There's no no other library that you have to get or use. Just one single Hazelcast jar. Okay, so Hazelcast is a distributed implementations of all this good stuff: map, queue, set, lock, semaphore, topic, executive service. So whatever. I mean, most of the Java util interfaces, we have distributed implementations for them. We do have a native C# Java client, REST, Memcache interface. We expose the cluster information so that you can know who the members are, who joined the cluster, things like that. Everything is dynamic. There's no fixed partitioning. Everything is dynamic. You can add more nodes as you need, or when a node dies, everything should be smoothly running. It's transactional and secure. We support symmetric encryption plus HTTP SSL in case you want to be really secure. Security companies do care about that. Use cases, we want to scale our application, of course. We want to share data. If the data is so big, like terabytes, we want to partition so that it can fit in the memory and process in memory. Send, receive messages across the JVMs, process things in parallel. Let's go over a simple demo. So let's say, okay, let me take, let me go, yeah, here, that's good. Okay, I have this zip here. You can download that zip, hazelcast.com, and then when you unzip, you should see something like this, bin directory containing scripts, and we should have Java docs and manual, libraries. That's probably the one that you'll be using, the just single jar. If you are connecting to a Hazelcast cluster from remote places, or if you want to become a client to the Hazelcast cluster, then you use Hazelcast client. If you're running Hazelcast in EC2 and you want to take advantage of auto discovery in Amazon EC2, that's what you need. Or if you want to use it as a Hibernate second level cache, that's what this is for. If you want to attach to J2E transaction, that's the resource adapter for that. If you're a big Spring guy, then you definitely need this. If you need just simple HTTP session clustering, you need this. Or you just take this single jar, says Hazelcast all, containing all, and be happy. Yeah. Okay. Single jar containing everything. You don't need anything else. But some people are so like strict on. I just need this and that. I don't care about the rest of the classes. Okay. Everything is in Maven. So just define a Maven dependency. That's it. So, as I said, the license is Apache right there. And we have a management center WAR file here so that you can manage the cluster. It's free for up to two nodes for testing purposes, and comes with this professional support. All right, so for the purpose of the demo, we have command line application. So it reads my commands and parses my commands and does Hazelcast calls. Okay, so I'm going to run a command line test application or demo application. You can I want you to be able to go home, download the thing, run this application so that you can start playing easily. You can get started quickly. Where are we? Not this one. So I'll get into this. Where is that thing? Okay. Bin directory. So I should be able to. Okay. Where are we? Yeah, I'm here. Okay. sh.run sh is the test up command line application. So this guy will start and say, hey, there's only one member. It's me. This is me. And my IP is this. And if I say map.put one, let's say SF, now if I do m.get, map.get, it will tell me SF. Of course, if I then go and start another instance, it will pick up the next port and hopefully they will cluster and we should be able to see the entry that we entered. Right, so now they're clustered. If I do m.get from the second node, I got it. So if I open for fun another one, blah blah. So the question here is that where do you think the entry is? Like I have 3 nodes right now, but I have 1 entry. It's somewhere, right? Is it on every node? Is it on 1 node? So Hazelcast is Hazelcast will partition your data, your map, and distribute it onto nodes. So it's not a full replication thing. It's a partitioning with replicas. So for each map, you can define the number of replicas. So the default is 1. If you just start, it has 1. So let's put more data. Like there's a put many command that we made it up. Okay, just to make things easy. I now have I just added 100 more. If I do m.size 101, you got the point. So we're sharing the map, and it's the entries are spread across nodes. Okay, now one of the good things. So it's a straight map, Java util map. But it's a little more than that.
So when you're doing an update from another node, you go to the master partition.
So okay. So in Hazelcast, there are internally. You don't have to know any of these, but I'm just explaining how it works. Actually, knowing these things is very nice, but when you're writing the code, you don't have to. You're using the same interface. So internally, there are 271 partitions. They're virtual partitions. There's nothing really partitioned. So we hash the key and mod with this partition ID, partition number, count, and then it will tell us what partition this key falls into. And on every node, there's a partition table. It tells me which partition is owned by which node. Then the put will be routed to that owner node. Because so when you're doing a get, it same happens because you have to be reading from the even if you are the backup of that key, you should not be reading from the backup. You should be going directly to the owner for consistency. You can enable backup read if you want to, but default is no read from the backup. You had a question? Say it again? No. Yeah, so the way we do it is also that we serialize your key into byte array and then hash it, take the hash, our own hash function, and it will, from the hash function, we define the partition, and then from the partition we define the target. Okay, so we extended map. Of course, it's actually concurrent map. So that means we have put if absent, replace, and things like that. But we extended regular Java concurrent map. We added things like queries, listeners, logs, things like that. So if I do m.log, meaning get map and then map.log, real API, and then pass the key. And now this node owns the log for this key, not the entire thing, just for this particular key. So if I do something like I'm from Istanbul, so let's try to overwrite that. So what do you think will happen if I hit? Obviously, it's locked. I should not be able to do it. So it will get blocked until when? Obviously, until I unlock the key. So it's returned. So of course, so I can also add a listener to it, like map.listener. Now this node is listening for the updates. Now if I do m.put from another node with 2 being New York, okay, then on this listening node, we should get an event saying that it is updated, it's added, right? So straight map, but with more more things on top.
So it has a partition. Does it also have a replicator?
So replicates to for
Yeah, I know what you're going to say.
yeah.
No,
Okay.
I'm saying replicated.
Full replication, you're
Full
saying?
replication.
No. So Hazelcast is always partitioned with replicas, and you define the replica space. But if you want, you can say I want 5 replica. You can. The way Hazelcast is designed is that we don't care about small. I mean, no, I shouldn't say that. But it's designed to scale to hundreds of nodes. That's the idea. So scaling means I should not be copying things on everywhere, right? So I should not be replicating everything to everywhere. So everything should be partitioned in a way that I can, if I add more nodes, I should be almost linearly scale, right? That's the idea behind it. So everything is designed to scale.
But I guess what I'm asking ultimately is, can I use a single program for multiple data so that I can issue a command to all the cluster members and have them operate on their data? You see what I'm saying? Like, can I say, go and do this, and then within the Java, and then have them operate on whatever their local data is. So an SBMD model, as like a grid type name.
Okay. Yeah, I understand.
That's why I was asking for replicating.
Okay, yeah. So actually, not replicating is a nice thing when for doing what you're asking. Like, so we are partitioning, right? So then let's say we want to calculate. Let's say yeah, we want to calculate. Yeah, right. Just for fun. So since everything is partitioned, I can issue a command saying that take this code, run on every node, and that code will be only operating on the local entries, so that way I can process the entire thing in parallel. I don't have to fetch things and process it, or I don't have to go one by one. I can say, go, take your data, process, and give me the results. So, parallel processing.
They can do that?
Yes. So you can add global listeners like this one, or you can add a local listener listening the data that's on you. So locally maintained data. So we extended, as I said, map. We also added new things like distributed queue. So like if I offer something from here, hello, I should be able to take it from here. So it's a regular Java blocking queue, but it's distributed. So if the names of the queues are the same, then you're operating on the same blocking queue. It's a FIFO, so it's still FIFO. Sure.
Is there any way provide kind of additional filters? What kind of value I want to get specific node for specific queue?
Like filtering the queue?
Let's say I put in some values into queue.
Okay.
And I want some certain values to be processed on some specific node.
Oh, okay.
Is there anything?
So.
So let's say I'm putting values, right?
Mm-hmm. And then these values.
Numbers.
Mm-hmm.
I want to be processed on node 1, and strings I want to be processed.
Then you probably should have 2 different queues, and put the numbers into numbers queue, and the guy who's processing. Yes, yes.
But
And
no filtering, additional filtering criteria when taken.
I understand now. Not yet, but that's a good addition. Yeah. So maybe looking at the attributes of the items that you're putting in, it might be routed to a different thing, right?
Exactly.
Okay.
Like you can distribute
Yeah.
when
Yeah.
I put some execution,
Yeah.
I can provide
Yeah.
some key range where the distribution.
Totally got it. Yeah. Or like adding a consumer that will consume based on a criteria.
Yeah.
Okay.
What happens if you lose a node that has a lock?
Very good question. Should we try that? Yeah. Where should I get the lock? For here? Yeah, which one? Which just is it? This one is good. Okay. All right. This guy has a lock. Now this guy is trying to update that to Talib. I don't know. Obviously it's blocked. Oh, okay. So if you want me to kill this, all right. Control C, was it? Okay. Boom. So it got it. It's not blocked. So if I do m.get, what was it, 5? Yeah.
Nice.
See, you did believe that I was afraid. Awesome. Good actor.
But why wouldn't it have been locked on the replica?
Say it again?
Didn't you just lock that and you killed it? So why wouldn't it have been locked on the replicas?
Okay, so locks are also, it's been recorded, that's why I came here. I know I'm loud enough. Locks are also, yes, backed up, so that if the lock holding node dies, you had the lock, you should be able to keep going, right? That's true, but in this case, we'll kill the guy who had the lock. If I'm the owner of the lock, if I die, I should release the lock because I died. I'm the owner of the lock, and I should, when I die, my lock should be released.
But doesn't the replicas come forward and take over his job? Take over where he left off?
But okay.
And shouldn't they just like be that way? Or,
But who? Okay, if yes, who's gonna unlock? I am the owner of the lock. I can only unlock it.
I see.
Okay.
Replication is one, and if I contain the data, and if I go down, what happens with the data?
Say it again.
So if I've set replication to 1,
Two one. Yeah.
and I have some data, so if I go down, what happens with that?
So backup count 1 means, or replica count 1 means there's one other guy holding the data, right? So if one of the guys dies, what do we expect? We should not be losing in data. So currently, this is how it is, right? So the default is backup count is 1. So if I kill any of these guys, I already did actually, right? So what was the number of entries we had? 101, and then 102. It should be. Yeah. Let me keys. Okay. So. Okay. These are the entries still. So we had 2, 1, 2, and 1, 2, 5. Yeah, we have all of them, right? So if we kill, of course, we had the backup somewhere, so it did recover. So actually, I wanna become a little quicker. I wanna speed up the things. So if I deploy the WAR file somewhere in a Tomcat, I'm gonna log in and see what's going on inside the cluster. I don't know if it is gonna be looking good here.
Since you killed one of the nodes, has it rebalanced the data to have still one backup?
I was gonna show that. That's so. Yeah, please. Yes. So right now we have 2 nodes left. So and half owned by two guys here. So as you can see, the partitions is like one has 50%, the other one 50%. Now I'm gonna and if I look at my maps here, so I should see a total of 100 and something. And these are the entries. So this guy has this many entries. This guy has this many entries. Okay, so we know that. So it's good. So if I open, or if I start another one, where was my nodes? here. Okay, so this is the one that I killed. I'm going to start it again. So and I want to watch this. So the third guy will come up, and I should see the third member here, and it will start empty, and then it will start acquiring some of the partitions. So you already got 29 of them. So let me go to here and actually home and see it. Okay, so we had very tiny data, so it did the repartitioning very fast. But if you had like millions of entries, then it was going to be doing slowly, like getting one partition, second partition. So eventually, in some time, like 20 minutes or something, it will get equally partitioned onto 3 of them. So, yes, go ahead.
Can you tune how quickly they rebalance?
No, no, and yes. No meaning it has a fixed logic internally built, like it has to do one by one. We don't want to migrate in parallel. Why? Assume that you have 100 million entries, okay, on a 100 node cluster. So we don't want you to because the migration, I got into details very quickly. I should have, let me follow the.
That's the exact reason I was asking. We don't want to affect the performance of those servers just because it's perfectly data.
Yeah, so
Now is a question to speed it up.
But then you're affecting something else. So here's the thing. Let me go over the demo. The presentation, I'll be answering your question. I totally understand your concern. So as I said, it's partitioning thing. This is the way we find the partition ID for a given key. And then, so these are our members, 3 members. And as you can see here, or there, these are the home entries, and these are the backups. Okay, so now let's say the new one is added. As we saw, so eventually we're going to be migrating some of these partitions, and eventually become what, equal, right? But I said migration, so migrating the data. So if you have tons of data, and migrating if you migrate in parallel, we might, so while migrating entries, invocations should be redoing, because I think that he has the data, but he's about to migrate to you. If I go to him to get the entry, he should not be giving me, because he's migrating that partition to you. So the question becomes, what if that migration takes a lot of time? So we don't want that too, right? So because so if you do the partition migration in parallel, then the number of hits that's being redone or revoked will be increasing, right? So that's also a problem. So what we are trying to do is, as you're adding nodes, your performance should not degrade. That's why we are saying one partition at a time you should be migrating. Will get blocked until. That's why it should not be in parallel, and one at a time is a good strategy here. Of course, as I said, you have 271 partitions. That means, or you can adjust that number of partitions if you have really big data, because that way your chunks are going to be smaller. So you can understand, like, you can calculate, like, hey, I have this many entries in each partition. That when we squeeze, when we zip that thing, it will be that small. Then it can be transferred in half a second. Oh, that's good. And that's the way you specify the number of partitions. Okay, that because we want to avoid also latency on the calls, right, during the migration. So so migration is complete. So what happens if a node crash? Of course, as we saw before, Again, we'll be gaining the backups are going to be owning the backup partitions. They're no longer going to be backup. They're going to be owners of the backup, and then taking backups so that we have enough backup in case of a next crash. So we are all safe. So node types.
So what happens if there's a query for that item at a time when the node has not detected that the primary is down? So what happens at that time?
There will be always a time between all these weird cases. Like so I'm thinking that the cluster is in this state, but it's not, because I just I need to wait a little more to understand the state of the cluster, right? There will be always latency between everybody knowing the entire state of the cluster. So I think that the partition is owned by him, but it's about to migrate. Obviously, I don't know the right thing. So for all these cases, from the caller perspective, or developer, it doesn't understand. It does a map.put underneath. Hazelcast tries to resolve that fuzzy state, right? So I think that this is it's dying. He thinks that he's starting, things like that. So it's going to be frozen. The operation will be blocked until the fuzziness is resolved. So I have to know exactly who owns it, and if I go to that guy, he should be able to say, yes, I own it. So both sides should be agreeing on the cluster state. So
if I start another application on the same subnet, which is using Hazelcast, how do I prevent that from stealing data from the existing application?
Okay. When you say stealing, it goes to security. Okay. It's
writing the data, right? As soon as another Hazelcast instance comes up, it will become part of that particular cluster and start migrating the data. Right?
Yes, yeah.
If I have two different applications and I don't want them to share,
you want to separate the clusters.
right?
Yeah. Okay.
And they are on the same subnet.
Yeah. So without really like a strict security, the easiest way of doing it, changing the group names in the configuration. App 1, App 2 in the configuration, then they won't cluster together. So they won't touch each other. Or if you're using multicast, change the multicast address so they cannot find each other. But if you're talking in terms of security, then you have to use our security module to ensure that everybody in the cluster has this good credentials to join the cluster. Yes, but these are common things. Even like imagine you have a production side and test environment, and developers are also on the same network. So we don't want developer machine to talk to testing servers, or mistakenly they're just joining the cluster, right? For those cases,
Do you have a configuration?
yes. So that's why we should. What I'm saying is we should have all group names for the different applications should be different, and also you can of course your network guys are going to be more careful about that. They're going to have virtual VLANs for all these setups, but from Hazelcast you can also divide these clusters, separate these clusters.
What if some of my servers are on a different subnet?
That's fine. What Hazelcast cares is the connectivity. So do you want them to join, or do you? Okay. So your network guys should enable TCP connection among these subnets. That's it.
But how will the discovery happen?
Still, multicast. If you're using multicast, they should open multicast for those subnets. Or if you're using TCP/IP with multicast is not possible, use TCP/IP clustering. Give the IPs directly. That's it. So let's look at this picture. So the servers are with the data on top are data servers. Servers without the data things pictures, they are called light members. They are not holding any data. They are the member of the cluster. They have very fast access to the data nodes. But so they are part of the cluster, but they are not holding anything on them. Okay. So maybe you want to separate your web applications from data servers, but still on the same cluster. Also on the left, we have native clients connecting to the nodes in the cluster. They connect to one of the nodes and delegates all the operations to that node. So everything. So if the client is doing a put is done on the connected node on behalf of the client. Okay, so it's very scalable to have hundreds of even thousands of clients. But the idea here, we should try to keep the cluster small to avoid network problems as much. And if we need thousands of things connecting to the cluster, we should be using native clients. Okay, so smaller the cluster, the better. Enterprise version is something that's we have something called elastic memory off-heap storage, so that we can avoid GC problems. Normally with the community edition, everything's starting on heap, which is subject to GC pauses. If you use elastic memory, then everything is stored off the heap. You can have 100 gig per JVM in-memory storage. And as I mentioned, you can also enable security, making sure that no bad guy can connect to your cluster. Off heap, it's a very simple configuration. You have the map definition. You'd say storage type of heap. Default is on heap. I'm going to pass the JAWS part. Sample code. So we saw that. Get the map, get the list. So on a single JVM, you can start a cluster of 5 nodes. This is how you do it. So you do a config, you create a config, and then you say Hilskas new instance. Every new instance is really a new node. Okay, so you can have 5 node cluster on a single JVM process. If you want to, 10 node. This is how we test things. So our tests will start 5 nodes, and then it will put things from somewhere and then remove things from other place, and make sure that we're getting the yeah. So if in the case of like Tomcat has Tomcat, you can deploy multiple web apps. You don't want yeah, got the point, right? Okay. Okay. Yes. Wow, that was quick. Okay, the question was, why do we need this? Why do we need to start multiple instances on a single JVM? And the answer is, in the case of Tomcat, for example, or any application server, you can deploy multiple applications, and most of the time you would say the applications should not be sharing the same Hazelcast thing. Every application want to have their own cluster. So this is how we do it. So for per application, you do Hazelcast, new Hazelcast instance.
This is a very valid reason. If you don't have elastic memory and you want to keep the GC size small, then you have a big machine.
Very, very possible. Yes, totally. So some people, as you said, would run 10 nodes on the same machine so that they can avoid GC. But yeah, yeah. So this is for running on the same JVM. You can always do what you're saying. Always do. So objects must be serializable. We rely on serialization. You can always implement Java serializable, but if you implement our data serializable, it's going to be way faster. Not because the Java serialization is bad and ours is better, because we think that you know how to serialize your objects. You don't have to give your object to Java to serialize and deserialize. Java tries to do a lot of things. So it uses caches and things like that. It tries to resolve all the problems possible. So, but in most cases, you don't need that. You know your objects. You know how to write and read them. So implement our data serializable. It will be faster. So in cluster interface, as you can guess, you listen for the membership events. You can get the set of members. In the distributive map, you can use, the put and get, but make sure you take advantage of put if absent. They're very good atomic operations, very valuable thing. In the queue, as you can guess, it's a Java util concurrent blocking queue interface. You do offer, poll, whatever. So it's all these blocking operations are all supported, all of them. Block, you can do two-way. You can use the lock interface, or you can we also have the locks per map. So as I showed in the demo, you can lock particular key, and this is how you do it. You get the map, lock the key, and make sure you, of course, do follow the pattern, like log, try, finally thing. Say it again? Oh, no, not right now. No. We don't even support conditions. Only the lock, unlock, and try lock. Try lock is also supported. Topics. Yeah, the idea here is that you have 10 node clusters, say. Some of them are listening for a particular topic. Whoever listening for this particular default topic will get the published messages from any node. Any node can publish, any node can listen. Whoever listening will get them. So it's like a JMS topic, but it's very lightweight. So 90% of the time, this is going to be what you need. But if it doesn't fix your problems, of course, go with the JMS. Yeah.
This is back to the locks for a second. Do you have any suggestions for implementing the behavior of re-entrant read-write lock?
It was asked before, and I have to think more. It's a difficult question. Yes, it's what we have is also already a re-entrant, but not re-write.
Right.
So you have to. Say again. Two bands. Oh yeah, got it. Okay. Yeah, same for the data centers. Like one data center should be holding the backup, and the other one should be the owner. Okay. Yes, we do. Yes, I can. So I think we're out of time. If you have particular questions, I'm here, and we have a booth at the exhibition hall. 5105. Yes. Please come visit us and ask her all your questions. I'll be around, so if you want to ask more. Thank you.